Hi everyone, welcome to my channel. My name is Fikret. This video is part of series on Apache Spark Essentials for Data Engineers. In this video, I'm going to cover user-defined functions. So let's talk about functions. So far, we have been using native built-in functions, but in PySpark, you can also create your own custom functions as well. There are many different types of functions available in PySpark. So let me start by a generic Python function that you can see in command 67. So let me run this. So what this function does, it just receives certain arguments like format, path, for example, and then it just uses standard read API format to read from specified path and specified format. So, and here you can see an example of using that function. One of the common ways of using this kind of syntax is that you can basically design transformations, generic transformations within your function. You can have data frame as one of the arguments and basically apply this transformation within your function. And then you can pass different data frames to this function to perform same type of transformations on different data sets. So to recap, this kind of Python functions allows you to apply common logic on entire data frame level, but there are some other functions which work on column level. So if I scroll down to command 68, I have example of a function called tax UDF, which takes price and quantity variables and multiplies them to get a tax amount. So this is scalar function. This is also called Python UDFs, and notice that I am using UDF decorator for that. Alternatively, I can also specify data types that this function expects in the bracket. And once you define your scalar function, you can use this function as part of your expressions, just like this, where I use tax UDF on top of price and quantity columns. Here is the result of this calculation. It's important to know that Python functions designed this way are not recommended, especially if you have large amount of data to apply this function, because these transformations are applied on a row by row basis, which is not very performant way of doing things in Spark. Let's take a look at other types of custom functions which are more performant. So here I am using same Python function with UDF decorator. However, I use arrow keyword, which allows you to leverage Apache arrow technology. With this extra keyword, you still get row by row processing. However, your performance becomes slightly faster due to the advanced capabilities of Apache arrow. So if I run this, you may not notice performance difference. So let's take a quick comparison. Given that my dataset is really small, so if in the first case I had around 9 seconds execution time, here I got 10 seconds, but you will see some performance improvement if you are using much larger data sets. So again, this is still not best way of using UDFs because of its row by row processing nature. Now let's take a look at different types of functions called Pandas functions, Pandas UDF. Pandas UDFs can be different depending on the way we are passing arguments to that. So here's a first example. So it's called series to series. So declaration of these functions is similar to Python function, except I specify Pandas UDF here. and I say my argument is expected to be float type. However, here's the biggest difference. So I have a first argument where I say my argument type is Pandas series type. My second argument is Pandas series, and I also specifically say my output data is Pandas series. So series is nothing but number of rows. The definition of the function is similar to what we have seen with the Python function. However, this small difference in the way of defining function makes big difference in terms of performance. Because instead of passing one row at a time, we are passing batch of rows from data frames. So, usage of this function is similar to usage of Python functions. You simply use that with column transformation, and you just specify the function name and provide arguments. So as you can see, by simply reshaping this function and changing the decorator type, we can achieve more performance, more scalability and performance. So if I scroll down to see the results, you can see that this operation has completed in less than 2 seconds, which is much lower than the Python function calls that we have seen earlier. So far, we have considered functions where the nature of your transformations are batch transformations. Here, for example, we simply multiply 2 columns together. However, in some cases, you need to have row-by-row processing logic in place. Examples could be maybe calling some API for each row in your data set, or maybe applying some string transformations on each string coming from your data frame, right? So in these cases, you can use iterator of series to iterator of series type of Pandas function. So here I have example in command 72. There are a few differences in compared to series Pandas function. So in this case, my argument is iterator type, which works on Pandas series. My output is iterator type as well. That means that I can refer to this argument as some kind of list or iterator. So this is what I am doing within this function. Basically, I go over each row within this iterator and I apply certain logic. So in my case, this logic is simple, and of course I could use batch logic. But again, in some cases, this batch logic is simply impossible. Another good argument in favor of this type of Pandas UDF is that if you want to do certain operation before you go over your iteration. So for example, you might want to have some initialization here, some operation here, which needs to be applied for all rows. So you can do that upfront before your iteration starts, and then use this value or calculated state here in your calculation logic. In terms of referring to this kind of function, as you can see, there is not much difference. So we are calling it as part of with column transformation, just like we did for other type of UDFs. Another more complex variation of iterators to iterator mapping Pandas UDF is called multiple iterators. In command 73, I have example of functions where I have more than one iterator arguments. To do that, I am using tuple element, and I specify number of Pandas series that needs to be supplied. So in this case, I'm expecting 2 columns here as part of this tuple. And here's an example of transformations that we can place within this kind of function. So let's continue our discussion with group mapping functions. These Pandas functions are great for aggregations type, where you want to slice your data by certain grouping criteria and then apply a certain transformation logic for each group. I have an example of such function in command 74, where I am applying group by on top of my data frame. So in this case, I am grouping my dataset by product name. And then I use applyInPandas function to call my custom function. So here's a definition of my custom function where I perform some aggregations on top of data frame that I receive as part of argument. And so you can see that in this case, my custom aggregation simply takes a list of client names and then for the same product name, and just concatenates them together. So to achieve that, I'm using pandas lambda x and the list functions here. And here's the results. So for each product name, I have aggregated all my unique client names in the client name column. Notice that I am using schema argument to refer to this kind of functions where I specify schema of my output data frame. So in this case, it's product name as a string type and client name as array type. To recap, by using applyInPandas construct, you can squeeze your data sets. So in other words, you can take larger data sets and apply a certain transformation and make it smaller. Sometimes you also need to achieve opposite effect when you need to produce more rows from your data sets. So let me show another example where I use mapInPandas function. So this is my command 75. But here I use the data frame created in the previous step, which is aggregate, to get detailed data set. I have row by row iteration, where for each row I apply explode function on client name columns to get all these values in separate rows. So here's the results. So as you can see, my data has returned to its previous shape. That's all I want to cover about user-defined functions. Thanks for watching, and I'll see you in the next part.